All right, IBAISL2, we've reached the end of chapter 2, which has been our triangle 3D geometry chapter. The first thing we started learning in this chapter was we didn't actually really learn it. It was just sort of some presumed knowledge about right triangles. You might be expected to use Pythagorean Theorem. In fact, that seemed to come up a lot. A squared plus b squared equals c squared with a right triangle where c is the hypotenuse. There's also times where you've been asked to use Sohcahtoa. Remember that stands for sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. Something that does come up in certain triangle problems is that all the interior angles of a triangle sum to 180 degrees. Now, I put that in the right triangle section, but it's really all triangles that's for. So we'll put a little note. This is all triangles. Then we started talking about non-right triangles. We learned the law of sines. Remember, that's like sine of the capital letter over the lowercase letter. So sine of the angle over opposite side equals sine of any other angle over the other opposite side. Law of cosines is another big one when you have all three sides of a triangle or an angle sandwich going on. That's what? A squared equals b squared plus c squared minus 2bc times the cosine of capital A. It's always the small letter that you start with is the big letter on the end, and then it sort of looks like Pythagorean Theorem, and you subtract those two letters again. Yeah, it's in your notes. We also learned how to find area of a triangle. Now, I'm not talking about 1/2 base times height. I'm talking about when you only have an angle and two, like the angle sandwich situation, where there's two sides and then an angle between them. You can use this formula here. 1/2 AB sine C. If you stack two triangles on top of each other, you sort of make a parallelogram. So I hesitated to even put this in the notes because you can sort of figure it out just by cutting a parallelogram into two triangles. But it is true that a parallelogram formula or area is AB sine C. Notice it's the exact same thing as the triangle, but the 1/2 is gone because when you double a triangle, you get a parallelogram. Know how to find the area of a sector. That's theta pi r squared divided by 360. Remember, we never did radians. We always did degrees. Make sure your calculator's in degree mode as well when you're calculating those. We ended the unit talking about 3D geometry. You might be expected to draw or know how to work with certain prisms and cuboids. Within cuboids and prisms, they had you guys finding distance between 2 points, certain vertices, connect the dots and try to find the distance between them. That usually involved trying to figure out if it was part of a triangle slice through the cuboid and trying to figure out what parts you had and didn't have, and then either using Pythagorean Theorem or Sohcahtoa or law of sines or law of cosines to find the distance between those 2 points. The last thing we did was volume and surface area of 3D shapes. The big 5 shapes all you're responsible for are the cylinder, pyramids, all different types of pyramids, pyramids with different bases, spheres, prisms, and cones. Remember, for pyramids and cones, the volume is the 1/3 of area of base times height. I think a lot of those formulas are in your formula packet, so I would definitely check that packet out to see what you need to, what you're going to have available to you on the test. All right, good luck with the review, you guys.